Sometimes it's difficult to step back, gain perspective, and realize how accustomed we have become to light. Lights are everywhere, in our houses, gardens, on our streets, and in our parks. We appreciate this light because it makes us feel safe. We can see what is ahead, and others can see us. Artificial light has consumed our world to the point where many of us have never experienced true darkness. Although light has helped us tremendously, as with most things, it is necessary to explore within the shadows and delve into what has previously been unseen. Could light be affecting us in ways that we do not yet understand? How does light change our ecosystem, and is it for the better? This summer, 2 professors and 4 students from Willamette University are working together to answer these questions through a scientific experiment along with individual creative projects. Throughout their experimentation, they hope not only to discover how light pollution affects ecosystems, but also to illuminate the value of collaboration between arts and sciences and bridge the gap that often divides them.
My name is Liz Perkin, and I'm a visiting assistant professor of biology at Willamette, and I'm a stream ecologist, and I'm interested generally in how humans affect stream ecosystems.
I'm Stephanie Lennox. I am a professor at Willamette University. I teach creative writing, but occasionally teach upper level classes. I'm also a writer. I have 2 books of poetry that have been published, and a lot of people think of the creative arts as being totally on the other side of the planet from science. When I write poems, I'm focused and working on finding the right word in the right place and the right rhythm, and there's a science to that.
My name is Jo Hernandez. I am going to be a senior this year at Willamette. I'm currently, no, I used to say currently, but I'm definitely a biology major at this point. But I also am going to probably minor in chemistry and probably English.
I'm Anya Romig. I am a chemistry major here at Willamette. I always knew I wanted to study science. When I came to Willamette, I was thinking maybe biology, maybe physics, I don't know. And then I thought, well, I've never taken a chemistry class, I should take chemistry, and I took intro here, and I never looked back.
My name is Tyler Griswold. I'm an English major. I really didn't actually declare until this last year. And my whole life, I've only ever thought of myself as wanting to be a nurse. And since we don't have a nursing program here, it was pretty much I could go and be a bio major and take a lot of classes that I actually won't need. But I figured out I really loved to express myself through writing.
So my name's Alex Wirt. I'm a senior chemistry major, and I thought it'd be really cool to be part of something that's interdisciplinary. So, yeah.
Are you afraid of the dark? Are you afraid of the dark? Are you afraid of the dark? So, are you afraid of the dark?
So my relationship with darkness is maybe a little bit more comforting than other people's relationships with darkness. I find comfort in knowing that half the world is asleep. I feel like I have more areas to explore in the dark that are completely different than they are in the light. You walk down a trail in the dark, it's nothing like walking down a trail in the light.
So I had the opportunity to go on a night hike with some of my friends, one of which was very familiar with the area. And he took us on a very treacherous path that was not the trail. And I remember wanting them to use headlights and flashlights so I could see where I was going. And I realized when we use those flashlights, we could see that much. And as soon as you turn it off and you let your eyes adjust, you can see everything. You can't see everything in perfect clarity or in detail, but you can see everything. And I really realized then that light, although it seems so welcoming and helpful and safe, it blinds you.
I really want to understand why it is that we cling to these lights so much. I think most of the fear is in our minds. I grew up in the country, so I grew up with a dark sky all the time. And moving here, I forgot how beautiful the stars were. I definitely think that our loss of the human relationship with the night sky does have an effect on us as people. You should be able to all see similar stars and understand that this is a planet and that we are in a bigger universe than just our own personal one. And I think by everything around us being so bright, we kind of lose our relationship with the bigger world.
We were on a camping trip at John Day, and we were at this campground, and the whole area is supposedly one of the best spots to see a truly dark sky, because if you're in the city, then all of the city lights are going to pollute the sky with light, and the stars are going to be a lot harder to see. So we were at this campground, and the sort of ironic thing that stood out the most to me is that from where I was sleeping, there was a bathroom light and like a street light that was actually kind of making it hard to sleep because it was so bright and there were no other lights around.
So even in the darkest places, lights are still common. They symbolize purity and progress, and for this reason, the notion that lights may be harmful to ecosystems is counterintuitive. However, there may well be a dark side to the artificial lights we all depend on.
When I went to Yachats, Oregon, I interviewed some people and asked them what they knew about artificial light. And they both knew about the problem in bigger metropolitan areas, but I think they still didn't really understand like how deeply that affected small things like in ecosystems.
Organisms are intimately affected by the natural cycles of light and dark, and often they depend on the changing light as a trigger for specific behaviors. Owls hunt at night, roosters go to roost after the sun has set. Imagine how ecosystems might be affected if after the sun went down, the environment remained bright. This is the reality for many urban areas, and it is important to understand the extent to which artificial light is altering the behavior of organisms within these urban ecosystems.
I originally got into studying light pollution in my PhD. I was interested in working with a scientist in Berlin, Germany, and when I went to talk to him, he said, look, I have a couple different projects, and one of them was to research light pollution, and it kind of blew my mind. No one had ever talked about this before, I hadn't heard of it, and immediately I began to see the exciting potential. It's such a new field in ecology, there's so many different research questions to ask. But right now, for this project, the bigger question here is really, is there an evolutionary response to light pollution?
In order to answer this question, we turned our attention to streams. There are numerous streams in the area that are exposed to 24-hour light, as well as many pristine streams that are completely dark at night. By comparing how an organism from an urban stream behaves differently than an organism from a dark stream when exposed to light, we can start to identify whether they have evolved differently due to their exposure to light.
Right now, for this project, I've been focusing on the insects. Insects are an important part of stream systems. Insects are great because they've had many more generations of exposure to light. They might have had 100 generations of exposure to light, where a fish might have only had 25 generations of exposure to light. They're a convenient organism to kind of get at this question of, is there an evolutionary response?
Streams and rivers are teeming with insects. The ones that we most often see are fully mature and flying around, but the vast majority are small adolescents who live in the water. These young insects cling to rocks and thrive there for months before molting their skin and emerging from the water with wings. They then immediately mate and subsequently die. The specific insect studied during this experiment was the mayfly.
Mayflies in literature and art tend to be used as a symbol for the brevity of life because once they hatch from their larval stage, they tend to live for a very brief time.
But mayflies are very resilient and important insects. Their behaviors are also strongly connected to cycles of light and dark. They live under river rocks, eating the algae that grows there, and when they want to move through the stream, they climb to the top of the rock, let go, and allow themselves to be swept away with the current. This behavior is called drifting. In order to avoid predators while they are vulnerable and floating in the water, mayflies often only drift at night. In order to see whether mayflies change their nighttime drifting patterns because of artificial light, we built 4 artificial streams. On either side of each stream was a bucket from which water flowed and a tank catching the water. The room was split in half from floor to ceiling with a black tarp, thereby allowing half of the room to be kept completely dark during experimentation. The water was recirculated by a pump in the tank, maintaining a constant flow of water. Mayflies were placed at the head of the stream, and the net was placed over the tank to catch any mayflies that drifted. The streams were filled with algae tiles and rocks to ensure that mayflies did not drift due to a lack of food or habitat. 2 mayfly populations were collected, one from an urban stream and one from a dark stream. Each population was exposed to both 12 hours of light and 12 hours of dark in order to compare how the populations reacted under the different conditions. After the mayflies were placed in the streams, they were allowed to drift for 12 hours. The mayflies could either cling to the rocks and tiles or let go and drift.
And so what we're looking to see is if the insects from the lit urban area have a different response to the light than the insects from the dark area. So what would be kind of the most exciting result to have would be if the insects from the urban area drift just as much in the lit stream as they do in the dark stream. And if the insects from the dark stream don't drift under light, but do drift when it's dark. And so what that would show us then is that would hint that there's been some sort of evolution where the insects in the lit streams are basically kind of ignoring the danger that's posed by the light, because they have to drift at some point, and so they'll have to drift when it's dim as opposed to bright sunlight.
The most intriguing product that emerged from this research, however, was not the experimental results. Instead, it was the remarkable collaboration that was achieved. Biologists, chemists, writers, and poets came together to create the project and experienced firsthand the benefits of interdisciplinary work.
When I was a kid, I wanted to be an astronaut, I wanted to be a marine biologist, I wanted to be a writer, I wanted to be the president. And there was no sense in my mind that I couldn't be all these things all at once. And I think that sense of connectedness and immediacy is something we lose as we grow up. Collaborations allow us to sort of restore those connections.
We almost never work across departments, especially coming from the chemistry department and working with the biology and English departments. It's been a total collaboration that I've never experienced before.
You have 2 different minds coming together, looking at things in 2 different ways. That's going to give you a more comprehensive, real world outlook of something.
Whenever you have an interdisciplinary or multidisciplinary group like we have, one of the biggest strengths is that all these people have so much differing knowledge that can be brought together, and things like that. That's just a really great way to improve everyone's knowledge and experience doing research like this.
What does poetry do, or what does creative writing do different than science? I think I want to focus first on what they have in common, which I think is curiosity. Both biologists and poets, they look at the world and they wonder why. We all begin with a really good question. The difference, I think, is that scientists go about trying to answer that question, and writers just sustain the question, keep the question going, refine the question, ask more questions. Scientists are focused on answers, but an answer just leads to the next question. So maybe ultimately there's more in common than there is different between the 2 fields.
Just like how biologists and other scientists have been taught to read a scientific research paper, I have my toolbox to analyze and close read a poem. I like when you read a poem and you have to work it out, and you have to figure out the context of these words and how they work in relation to each other, and the syntax and the diction and the end stops and punctuation and all of this great stuff that hides the meat of something.
When I sit down to read a poem, I read the first 4 lines and I have no idea what I just read. And I realize that people think that when they read scientific papers, and that's why maybe they're influenced to stop reading them.
If you don't know these words and you don't know the format of a scientific research paper, you're kind of lost. You go into it and you don't know where to even start.
We use that specific language in our research papers so that someone can read through that, see exactly what you did, replicate it perfectly, and see if they get the same results.
I don't think that we can change all of scientific writing, because as much as I think that we should include people that aren't speaking that language in the discussion, scientists need to communicate effectively, very efficiently, with a language that they've studied for years.
And that being said, it's also super important to create something that's accessible for a general audience, because a lot of what scientists do affects the general public. As scientists, I think it's our obligation to translate.
There's less focus in the sciences on writing in an interesting way that's not just a carbon copy of the last paper. So it's been challenging, but also really fun to try to step back and simplify what I'm saying when it comes to scientific topics so that it would make sense to a general audience.
I find it oddly intriguing how I'm taking biology and putting it into English and translating really this research in a way that my fellow comrades can understand.
My goal when I give a scientific talk at a conference is to excite people about my research and have a nice storytelling narrative behind it that helps keep people's attention and also emphasizes what the importance of the work is, because that's one of the most critical ways to get people interested in your work is why is it important to them.
If we're creating something, you should go into it with a mindset of like, oh, how can I make this accessible so my information is disseminated in a way that people can understand in a variety of contexts? And that's exactly what we're doing with this grant. We're going from podcasts and blogs and videos and songs and short stories and all of this great material, all talking about the same subject. Mayflies are affected by light, and that we are changing the ecosystem just by having a light turned on.
And I love that mayflies are so small and poems are small too, and because of that people think they're insignificant, but they're not. They're there underneath the surface and they're waiting for a moment to emerge.
I realize more and more that there needs to be this group in the middle, and I think this project has inspired me to be that person that can go and understand that language and translate it to others that can't, to do the middle work, and to also bring back what they learned from one side to the other. Because I do think our research could be improved if we listen to people outside of our language, get a different perspective and allow that to change us and allow that to influence the way we think about our own experiments. I think it would be really helpful to constantly be more collaborative with all of our different departments.
There is a part of me that still wants to be the scientist. By participating in the summer experience, I get to, recover that little part of me. I brought some poems that I thought were sort of science-y, and Liz had a really interesting response to the poem. She was frustrated because it was focusing just on a certain aspect of an insect's life, the tail end, the part that is short-lived. This is the mayfly's retort, those lifelong dancers of a day. Enough already about how fast time flies, or how there's no time like the present. We are not your sacrificial symbol, exhausting ourselves with acrobatic sex, living only to breed, with no workable mouth, abdomen emptied, and nothing more to do. We weren't born yesterday, though you'd like to think we were, so you can conjure a catharsis from our ephemeral existence. What is it with you people and your tragedies? Thirsty for a glimpse of your own reflection, you fall head first into our rivers and drown. You tell stories, lie. You kill each other. Nothing but walking shadows organizing stars into heroes and monsters. Into all this we emerge after months or even years as nymphs with a mythology so deep and ancient you could not begin to understand.